Hello and welcome to another video by Siddha Education. We move further in our algebra unit on the mathematics course. Our latest topic today will be about expanding double brackets. So up until now, we have learned how to collect like terms. We have learned how to expand single brackets. Today, we are going to learn how to expand double brackets. This is a situation wherein which we have a set of terms within a bracket and a set of terms within another bracket, and they are not separated by an addition or a subtraction sign. So as you can see in this pair of brackets, there is no separation between the two brackets with an addition or a subtraction sign. What this means is both brackets are being multiplied together. Therefore, if we have two brackets and an absence of an addition or a subtraction sign, it means that they are being multiplied together. So for example, in this specific example we have on the page, we have open brackets x plus 5, close bracket, open bracket x plus 9, close bracket. Due to the fact that there is an absence of an addition or subtraction symbol there, means that both of these brackets are being multiplied together. Now, we've been told to expand. Now, we know from our previous knowledge that expand means to multiply out the brackets. Now, when we were expanding single brackets, it's where we only had one bracket, we used what we like to call the claw method. But here we are expanding, we are multiplying out double brackets, two brackets. So we are multiplying two brackets together. For this, we use a method which we like to call the FOIL method. The FOIL method, and we're going to demonstrate that to you throughout this video. Okay, so first of all, let's take a look at this example and then we'll be able to show you a demonstration of the FOIL method. So first things first, expand. Again, reminder, multiply out the brackets. So when using the FOIL method, what we first do is we first multiply the first term in each bracket together. So the first term in this bracket is the x here, and the first term in the second bracket is the x here. So we multiply the first terms of each bracket together. So x bracket x, so x multiplied by x gives us x squared. Then, so we have done the f from the FOIL, the f. Then we move on to the O. O stands for outside. It's where we multiply the two outside terms, i.e., the first term in the first bracket by the second term in the second bracket. So the two outside terms, the first term in the first bracket by the second term in the second bracket. So x multiplied by positive 9 gives us positive, let's draw that in a bit neater, positive 9x. There we go. And then, so we've dealt with the F and the O. Then I stands for inside, which means multiply the two inside terms. So the two inside terms are the second term in the first bracket multiplied by the first term in the second bracket. So positive 5 multiplied by x gives us positive 5x. And then finally, the L, which is for last, which is where we multiply the second term in each bracket together. So the positive 5 multiplied by the positive 9, which gives us positive, just remove that, positive 45. So let me just quickly explain that again. So first, outside, inside, last. We multiply, firstly, we multiply the first term in each bracket together. Outside means multiply the outside terms. Inside means multiply the inside terms. And last means multiply the second term in each bracket together. So we have gone ahead and expanded. How do we know we've expanded? Because our current solution or our current calculation does not have any brackets anymore. Why? Because we multiplied them out. However, we can see that there are some like terms here. So if we look here, 9x and 5x are actually like terms. Therefore, we are required to simplify also. Simplify or collect like terms. Now, when we simplify or collect like terms, on this channel, we like to use what we refer to as the shapes method. So we're going to go ahead and do that now. So first of all, the first term is x squared. So we can give that a rectangle. Then we have positive 9x. Now, x squared and 9x are not like terms. Therefore, we must give it a different shape. So we have an oval. Then we have positive 5x. Well, it's not the same. It's not a like term to x squared, but it is a like term to 9x because they have the same unknown, the same variable, the same combination of letter. Therefore, we give that an oval as well. And then finally, positive 45. It's not a like term of x squared, not a like term of 9x or 5x. So we give it a different shape altogether. So we can give it a triangle. So now we're going to go ahead and use the shapes method and collect the like terms, simplify. So we have x squared plus our two ovals, which give us plus 14x plus 45. Have we expanded? Yes, we have. How do we know? We no longer have any brackets. Have we simplified? Yes, we have. How do we know? We now have a shortened version of our expression. So we can double underline the answer and commit to that. Let's take a look at another example now. Again, we've been asked to expand. So if we're expanding, it means we're multiplying out the brackets. Therefore, if we're expanding a single bracket, we are using the claw method. If we're expanding a double bracket, we're using the FOIL method. Now here we have been told to expand x plus 9 all squared. X plus 9 all squared. Please note that I have said x plus 9 all squared. Okay, x plus 9 all squared. What that means is all of x plus 9, this entire expression here, is being multiplied by itself. Therefore, x plus 9 multiplied by x plus 9, not x plus 9 squared. X plus 9 squared would look, just bear with me a second, like this, x plus 9 squared. There's a big difference between x plus 9 squared and x plus 9 all squared. X plus 9 squared would in fact be x plus 81. Okay, but then you'll see that x plus 9 all squared is very different. So again, a quick reminder, okay, you may want to get this down in your notes actually to see the difference. This is what x plus 9 all squared looks like, and this is what x plus 9 squared looks like. Right, so you can pause the video and make a note of that. I'm going to move on. So let me just take this off our screen. Right, so as we said, x plus 9 all squared actually means the whole term whole expression x plus 9 multiplied by itself. So x plus 9 multiplied by x plus 9. Now, as you can see, there is an absence of an addition or subtraction sign. If there's an absence of an addition or subtraction sign, it means both brackets are being multiplied together. Now, if we were expanding single brackets, we would use the claw method. But here we have double brackets. We have one bracket here and we have one bracket there. Therefore, we are going to use the FOIL method. So I'm just going to write that down on the side as a reminder. Remember what FOIL stands for? First, outside, inside, last. So we're going to first multiply out the first term in each bracket together, which is going to give us x multiplied by x is x squared. Then we are going to multiply the outside terms, so x multiplied by positive 9, which gives us positive 9x. And then we are going to multiply the inside terms, which is positive 9 multiplied by x, which gives us another positive 9x. And finally, we're going to multiply the two last terms. So positive 9 multiplied by positive 9, which gives us positive 81. There we go. Okay, so have we expanded? Yes, we have. How do we know? We have multiplied out the brackets because our current calculation no longer has any brackets. I'm just going to write that x in a bit neater. There you go. Right, now, do we have any like terms? Yes, we do, right here. Therefore, what we can do is we can use the shapes method to simplify or collect the like terms. So let's go ahead and do that now. So I'm going to go get myself a different color, blue. First of all, x squared, you can give that a square. or a rectangle rather. And we have positive 9x, x squared and x are not like terms, so we'll give that an oval. Positive 9x, yep, it has the same, it's an identical term to positive 9x, so we'll give that an oval as well. Finally, positive 81 does not have any like terms, so we'll give that a triangle. Now, we can go ahead now and collect the like terms. So x squared plus 18x plus 81. Have we expanded? Yes, we have. How do we know? We've multiplied out the brackets. We no longer have brackets in our expression. Have we simplified? Yes, we have. We have shortened the expression by collecting the like terms. So we can go ahead and double underline the answer and commit to that. If you're unsure about those examples, take a look at, pause the video, take a look at those examples again. Let's move forward. Then we're told to expand x minus 6 all squared. Note what I said about all squared. Again, x minus 6 all squared actually means x minus 6 multiplied by x minus 6, because the entire term is being, let's get a different color here, all the terms are being multiplied by themselves. Okay, so again, what do we have here? We've been told to expand, which means multiply out the brackets. Do I have a single bracket? No. If I did have a single bracket, I would have used the claw method. But because I have double brackets, I'm going to use the FOIL method. Let me write that down on the side as a reminder for you. What does FOIL stand for? First, outside, inside, last. So let's go ahead and do that. So first of all, we are going to have, just bear with me a second, just change the color so it's a bit clearer for you all. X multiplied by x, which gives us x squared. Just remove these. There we go. X multiplied by negative 6, which is negative 6x. Negative 6, so I've got my pen. Negative 6 multiplied by x is negative 6x. And finally, negative 6 multiplied by negative 6 gives us positive 36. Have we expanded? Yes, we have. How do we know? Because our current calculation no longer has any brackets because we've multiplied them up. Now we need to check, do we have any like terms? Yep, we have some like terms right in the middle here. Therefore, what we're going to have to do is we're going to have to simplify or collect the like terms so we can use the shapes method for that. So first of all, x squared, we can give that a rectangle. Negative 6x, it's a different type of term. They are not like terms, so we'll give that an oval. Negative 6x is the identical term to negative 6x, so we can give that an oval as well. Finally, positive 36 does not have any like terms, so we'll give that a triangle. Now let's move on. Let's go ahead and implement or apply the shapes method now. So x squared, add our two ovals together, negative 6 subtract 6x, negative 6x subtract 6x rather is negative 12x plus 36. Have we expanded? Yes, we have. How do we know? We've multiplied out the brackets. Have we simplified? Yes, we have. How do we know? We've shortened our expression by collecting the like terms. Let's double underline our answer and commit to it. Excellent. Let's now move on to another example. Expand. Open bracket x minus 2, close bracket. Open bracket x minus 4, close bracket. Again, a reminder for us, between the two brackets, we have the absence of an addition or subtraction sign, which means that both of these brackets are being multiplied together. When two brackets are being multiplied together, when we're expanding double brackets, we use what we like to call the FOIL method. What does FOIL stand for? First, outside, inside, last. So let's go ahead and apply that now. First of all, x multiplied by x gives us x squared. Then we have x multiplied by negative 4. Remember, multiply because brackets means multiply in algebra. X multiplied by negative 4 is negative, let's go back to our black pen, negative 4x. Then we have negative 2 multiplied by x. So let me just draw that in. Negative 2 multiplied by x, which gives us negative 2x. And then finally, we have negative 2 multiplied by negative 4, which gives us positive 8. Have I expanded? Yes, I have. How do I know? I no longer have brackets. I've multiplied them out. Do I need to simplify? Well, in order to check that, I have to look at my current expression and to see if there are any like terms. Yep, I have 2 like terms here in the middle, right there. So I'm going to have to use the shapes method now to collect the like terms. So I'll just get a different color pen. X squared, let's give that a rectangle. Negative 4x. X and x squared are not like terms, so we'll give that an oval, a different shape. Negative 2x. Well, negative 2x has the same combination of letters as negative 4x. They have the same unknown, the same variable, so that is a like term. So let's give that an oval. And finally, plus 8 does not have any like terms, so let's give that a triangle. Let's add up the like terms. So it's going to get x squared, simplifying, minus 6x, because negative 4x subtract 2x is negative 6x, plus 8. Final check. Have we simplified? Sorry, have we expanded? Yes, we have. How do we know? We've multiplied out the brackets. Have we simplified? Yes, we have, because we've collected the like terms. So we can double underline the answer and commit to that there. Perfect. Let's move forward. Let's take a look at another example now. Expand. Open brackets 4x minus 3, close bracket, open bracket 3x minus 2, close bracket. We've been asked to expand. What does expand mean? It means to multiply out. So we have to ask ourselves the second question. Are we expanding a single bracket? If we were, we'd be using the claw method. But in this example, we're expanding double brackets, so we're going to use the FOIL method. How do we know we're expanding double brackets? Because of the absence of an addition or subtraction sign between the two brackets. If there was an addition or subtraction sign, it would mean that we have two separate brackets, but separate brackets being added together or subtracted together. But these are being multiplied because of the absence of the addition or the subtraction sign. When expanding double brackets, yep, you got it. We use the FOIL method. What does FOIL stand for? First, outside, inside, last. So let's go ahead and apply that now. So I'm going to get a different color so it's nice and clear. 4x multiplied by 3x gives us 12x squared. Perfect. Then we have 4x multiplied by negative 2 gives us negative 8x. Okay, once I've managed to change, there we go. I was having trouble there changing the color. Negative 8x. Then we can get another color. Negative 3 multiplied by 3x. Whoops. Right, there we go. Perfect. Remember, brackets means multiply, and this is why we are multiplying. Negative 3 multiplied by 3x is negative 9x. And then finally, negative 3 multiplied by negative 2 gives us positive 6. Excellent. Have we expanded? Yes, we have. How do we know? Because we no longer have the bracket. We have multiplied out the bracket. Now we need to ask ourselves, are we going to need to simplify? For us to simplify, we're going to have to see if we have any like terms. Yep, we have like terms right there. Okay, so what we're going to have to do is we can use the shapes method to collect the like terms. So first things first, let's get ourselves a nice bright color. Let's go for red. 12x squared, give that a rectangle. Negative 8x, x squared and x are not like terms, so we're going to give it a differing shape. Let's give it an oval. Negative 9x, yep, that will have an oval as well. Why? Because the two x's are like terms. Finally, plus 6, we'll give that a triangle because it does not have any like terms. Let's go ahead and collect the like terms now. We have 12x squared because there are no other x squareds, only one rectangle. Add the two ovals together, negative 8, or collect the two ovals together. Negative 8x subtract 9x is negative 17x. And finally, the triangle. Whoops, let's try that again. Presentation is very important, guys, which is why I am writing things nice and clearly for you. Plus 6. Right, have we expanded? Yes, we have. How do we know? Because we multiplied out the brackets. Have we simplified? Yes, we have. How do we know? Because we've collected the like terms. Let's double underline the answer and we can commit to that. The reason why I am repeating I'm repeating myself over and over again. It is so it sticks within your mind. If you are used to following these processes, it will become far more easier for you, and you'll be able to do it second nature. Right. Expand 4x minus 4 all squared. Let me repeat that again. Expand 4x minus 4 all squared. That means 4x minus 4, the terms will be multiplied by themselves. So 4x minus 4 all squared actually means 4x minus 4 all multiplied by 4x. Let's try that again. Whoops. 4x, whoops. 4x minus, let's try that again. Not having much luck, am I? Not to worry. Let's keep going. 4x minus 4. That's better. Excellent. Okay, so do I have a single bracket that needs expanding? No. If I did, I would have used the claw method. But because I have double brackets, I'm going to use the FOIL method. Now, what does FOIL stand for? First, outside, inside, last. So let's go ahead and apply the FOIL method. So first of all, we have, just bear with me a second. Let's change the color so it's nice and bright for you. 4x multiplied by 4x. That will give us 16x squared. Then we have 4x multiplied by negative 4, which gives us negative 16x. Then we have negative 4 multiplied by 4x, which gives us a negative 16x. And finally, we have negative 4 multiplied by negative 4, which gives us positive 16. There we go. Have we expanded? Yes, we have. How do we know we've multiplied out the brackets? Are we going to need to simplify? Well, if we do need to simplify, it will mean that in our current expression, we will have like terms. Do we have any like terms? Yes, we do. Whoops. Right there. Okay, so we're going to use the shapes method, and we are going to collect the like terms. So 16x squared, we'll give that a rectangle. Negative 16x, x squared and x are not like terms, so let's give that a oval. Negative 16x, x and x are like terms, so let's give that an oval as well. Finally, plus 16, 16 does not have any like terms, so let's give it a triangle. Okay, right, so let's collect these like terms here. Okay, let's get our black pen. So we have 16x squared, we cannot collect it with anything. Negative 16x subtract 16x is negative 32x, and plus 16. There we go. Have I expanded? Yes, I have. How do I know I've multiplied out the brackets? Have I simplified? Yes, I have. How do I know I've collected the like terms? So I can commit to double underlining the answer, and that's going to indicate that that's my final answer there. Okay, so we've gone ahead and done all the examples. If you're still unsure, take a look at the video again, try some questions for yourself, practice, practice, practice. Thank you for your time, and keep watching our excellent videos.